Hello, Monica. How are you? How's everybody? Hey guys, sorry I'm late. I had to reboot my system, and I hope everybody can hear me. How's everybody?
We can hear you.
You can hear me?
Yes.
Okay, that's good. How's everybody doing?
We're doing fine.
All right.
Well,
Hey David, I can hear you. So, how's everything?
Um, Busy week, but everything is good.
Okay. Sorry, I had to reboot my laptop, and I hope you guys didn't wait too long. So right now, let's give it maybe another 1 minute, then we get started. Okay. How's everybody feeling? How has the class been treating you so far?
It's been very good.
Okay. How's the material? Are the material digestible? Like you can read, understand, and be able to like make things out of it?
Yeah,
Okay.
it's. I've had books on Python before, but a
Okay.
lot of it did not make sense until it was presented the way you did. Because I never committed to the books.
Oh, okay. Okay. That's good to hear, man. I'm really glad it's making a big difference. Because I mean, once you get to know, or once you read it once, then you come back and read it again, it makes a
Yep,
lot of sense.
yep.
Yeah, that's good news. So I'm going to go ahead and get started. And again, my name is George, and this is our second iteration of the Zoom session on Python programming. So it's going to be part two. And as you can see on the screen, we have quite a number of stuff to cover, but we will try to be as brief as we can so that we can get some time to be able to answer questions and also be able to explore some of the possibilities of what we'll be doing as of these coming days. Okay, so I am following, as usual, the lesson plan we came up with the first time, and it started with classes and objects. Okay, and we will follow that with functions or functional programming, which will also be followed by file processing and pickling. And of course, those first three are already in the notes, which I sent out. So maybe the only one which is not in the notes will be the operator overloading. So what I wanted to do, if possible, and I'm assuming that everybody had a chance to read the notes, as in classes and objects, functions, and file processing. Of course, I'll expect some questions, but If you allow me, I would like to start with operator overloading because it's an area we have not touched. So I'm gonna go ahead and get started on that part of it. So, okay, without any wasting time, let's go ahead and just give you a clear explanation of what operator overloading is. Now, you remember that when we first started the class, we were doing a lot of introduction to like the operators. We have the multiplication sign, we have the plus sign, we have the division, we have the exponential, we have the modular, and all those. Now, you find that some of the operators like the plus sign has more than one function it performs. And when operator as in 1 plus 2 equals to 3, the same operator, we can also use it to say, let's say first name, John, and then plus second name, Doe. Now, the plus sign, when we use it in the string, we basically call it the concat. We do the concatenation. So we concat, basically we bring the two together so that they can make some sense out of that thing. So let me go back real quick and make sure we get to that portion of operator overloading. So this is it. Okay, each operator can be used in different ways for different types of operands. Now remember, if we say 1 plus 2, the 1 and the 2, those are operands. And the plus sign is the operator. So we use the operator to add the 2 and add the 1. So the fact that we can use it in string and then we also use it in the calculation, that gives it the name operator overloading. So here we have an example of a plus operator used for adding two integers to give an integer as a result. But when we also use it in float operands, say 3.2 plus 2.3, those are floats. We use it there also to give us the result of that particular float addition. Okay. We also use it in strings when we want to concat, like concatenation of maybe 2 or 3 or more items in a string. Now, this different behavior of a single operator, for example, for different types of operands is called operator overloading. Now, they use, of course, we just say plus operator with different types of operands. So, overloading is achieved by defining a special method, okay, in a class definition. Now remember, we talked about the objects and the classes. So right now we are also referring to the object and the classes, which means the names of this method start and ends with a double underscore. For example, we say the underscore here, we put 2 doubles and then we put the add for addition and then another underscore. And anytime you bring this particular 2 parentheses in Python, that is understood to be a method. Now, method is a function, so to speak. Okay. So both integer class and string class implements this addition method. The integer class version of addition method simply adds 2 integers, where the string class version concats the 2 strings. Okay. Okay, in the expression for, let's say, x plus y, Python interprets it as x underscore underscore and underscore underscore in bracket y. So the version of the and method call depends upon the type of x and y. If x and y are integer objects, then the integer class version of the and is called. On the other hand, if x and y are list objects, then list class version of the and method is called. Okay, you'll soon realize how this works. I have a few examples to show. Okay, for example, we have, say, x and y. Remember we did this whereby we can actually chain, we call it chaining, whereby you have one variable, another variable, and then we equal to one value, another value. So we have x comma y equals to 10 comma 20. And Python will be smart enough to know that x will be equivalent to the first value, which is 10, and y will be equivalent to the first value, second value, which is 20. So that means in the memory somewhere, the value of x, which is 10, plus the value of y, which is 20, is going to be added using the operator of the plus sign. And therefore we get the 30, which is an answer of adding 20 plus 10. So we can alternatively also say x underscore underscore add underscore underscore y is the same as x plus y. So this line right here is equivalent to the same as the result we're going to get from the one above. So we can say x comma y. We say x in this case is going to be 11. I'm sorry. X in this case is going to be 11, and y is going to be 12. And then we can say comma 1,000 and then 2,000. Now when we call that, x will take a position of 11, y will take a position of 22, and then it's almost like now we are bringing two, remember the list we did? We are bringing two lists and joining them. It's almost using the extend function to join two lists. In this case, so we say y underscore underscore, x underscore underscore y, the same as x plus y. Okay. Of course, I'll share the notes with you. So if you don't understand it, please feel free to ask so we clarify that part of it. Okay. Now, there are operators, and then we have the special methods, and then we have their descriptions. So I put this together for illustration. So we have the plus sign, and remember we just say the underscore underscore and the word and then underscore underscore. Now remember, anytime we're dealing with a method, we have to use a self as a keyword. So self and then the object. So in this case, this will mean when we do that means we add. When we do that, sub means we subtract. So we are doing operator overloading here. We do that. MUL means we multiply. That one means we get the power of, which is an exponential of the value. And then this one is a true division, simple division. And then, of course, we have the integer division. We have the modulus, the equal to, and all through until we get the last one. Now remember the last one and the second last one those are for calculating numbers, and those are basically built-in Python functions. So the string underscore underscore string and underscore underscore length, or for length, those were covered way back when we first started, and those are actually internal functions. We call them built-in functions for Python. Okay. So operator overloading, again, you notice that these last items, the ones, right, length and string, okay, are not operators. Instead, they are built-in functions. But if you want to use them, then your class, with your class, then you should be able to define their respective methods. So I'll, let me see if I can share this with you. Okay. Okay, so I made a program here. I hope you can see it. So we did import, where anytime you're doing math in Python, you have to import the math. This is a library. And then we declare a class. We call that class a point. And then we basically just pass two determined parameters with their arguments. So we have the x equals to 0 and the y equals to 0. And then we just use the same way we did with the self. Remember, anytime you declare that, you have to use them here too. So we assign the x and the y to these values here. And then once you do that, then we get the x coordinate. So we return, first of all, we have to declare this function so we can be able to return what x is. And then we also set the coordinate for the y. Okay. This might not make a lot of sense, but this is, for now, is just to illustrate how overloading works for the operator in this case. So we came back here and then we say we get the y coordinate, and then we also get the x coordinate. Now we're returning the y and then we're returning the x, and then we set the y coordinate, and then we get the current position. Okay. So I'll also share that with you. And when we run this program, probably this is not a good example. It's too lengthy. But I'll probably just go ahead and explain it real quick. But what we did here, we using the LT for less than, we're using the SB for subtracting, we're using the AD for adding, we're using the less than or equal sign right there. LE, less than or equal sign. And this one is LT, less than. And then we also overloaded, we used the greater than sign, the GT. And then we also did the greater than or equal sign. So this is basically showing us how we can declare this as an object, and then we use a function or the methods of those objects to call and be able to get the results. So when we do this, when we run the program, we say now it's going to be able to print the results. And those results will be like the first one, if P1 is less than P2, then we know we know the answer to be either true or false. Okay, this is I kind of like understand this might be too much right now, but let's go ahead and run it. So is P1 less than P2? If it's true, it's gonna return true. So it's basically we using operator overloading to add, to subtract, to get the greater than, to get the less than. So this right there is just to show you how we can apply the operator overloading based on what we covered. Let me see. Now that's based on what we covered here, this range. So when I share those with you and then I give you this particular note, then you'll be able to see the example how it should be applied. So don't worry about the boring detail of it, but look at what you can do with it in terms of getting the results. So, and also understanding what it means to do the operator overloading. Okay. So that's the same thing right there. So we just did the table. Okay. So we can use it in functions to customize those functions. So we can say a plus sign, negative sign, or greater than, equals, and all that. We have now a way of doing that. So that's like, this is for the equal sign right there. And this for the addition. Now, in Python, overloading is achieved by overriding the method. So we can override the method, which is specifically for that operator. In the user-defined class, for example, instead of using a plus sign, we can just use this one right here. So we declare the variable here, and then we return in that particular method. So sometimes you find that, sometimes you find that in certain programs, somebody might just decide to go the direction of, instead of using the plus sign, they might decide to use the add, the underscore, underscore, add, underscore, underscore. So when you see that, you should be able to understand without being thrown off completely, because different people will program differently, while the result will probably be the same. Okay. So this is another example. So we come here, we say 10, we put 10 in X, put Y, and put 20 in Y, and then we say X plus Y equals to 30. Do the same. We can say now let's go ahead and assign 10.4 to Z. And then we say, remember X was 20, X right up there is 10 already in the memory. So we say X, which is 10 plus 10.4, is going to be 20.4. That's simple math. The same operator, which is an addition, we can also use it to add the word hello and the word world. So we use the same. Python has the intelligence of knowing that when we add integers or floats, we need an answer for that. At the same time, it knows that when we add two strings, we are basically trying to achieve one particular long line after the concat. Okay, so this will be hello world, of course, adding hello plus world. Okay. The same applies to here. Passing, say we want to pass salary of a person. Person A will be probably 5,000, person B will be 10,000, person C will be 15,000. Now using the plus sign, we can add those. A plus B plus C will definitely be 15 plus 10 plus 5, which is 30,000. So using a plus sign, there also is another indication of operator overloading. Now remember, for example, in the context of operator overloading, chaining is when you use an operator, okay, multiple times in the same line. And let me show you, okay. So say A, comma B, comma C, okay, equals to 10, comma 20, comma 30. So we know that when you say A, it's going to be for 10, B is going to be for 20, and then C is going to be for 30. That, when you can declare that, when you do that, it's basically what we refer as chaining. Now, to make an overloading operator capable of performing chaining, we usually return the same user-defined type in the overloading function. So remember, this is now addition, and this is here is a function. So the xy here will be a variable we have to return so that we do the calculation with it. So we say, go ahead and return the person, and then get the salary times, get the salary plus xy dot salary. So that will be able to return some kind of calculation based on the numbers here. Okay. All right. I hope we are getting it, are we? Everybody feeling good? Any questions so far?
So far, so good. Absorbing it.
All right. All right. So right here, we can say salary. We say self dot salary. Remember, in object and classes, we did that. So we say A plus B plus C is equivalent to, we split that, we say A plus B, and then we bring C. So returns AB, returns integer, and then the C here will return the person. Now, if you do that, then this will be undefined. So if you were to do this thinking that it's going to work in the chaining, it's not. But instead, on the right-hand side is the one you probably want to adopt. So you say A plus B plus C, return A plus B, and then plus C. So AB is a person, plus C, another person. And then when we do the addition here, it takes us back to this particular formula, which will be, we basically add the salaries of these people, A plus B plus C, to get the final result. Okay. So that's how chaining works. So when I share the notes, you'll be able to probably comprehend and then see how it works. So you know the one on the left is not going to be returning good results undefined, because one of those is an integer. We cannot add an integer to a person. But if you go to the right, then we have the AB as a person plus another person. So they are all on the same, like we can only add integer plus integer. We cannot add integer plus string and then we expect something out of it. So that's what this is about. Okay. So again, clear indication how those goes to the true division, the multiplication, subtraction, and the addition. Those are basic arithmetic operators. On the right, those are the methods and how we overload them. Okay. And then these are the comparisons. We normally compare, is it less than, bigger than, or less than, larger than, or greater than, or is it not equals to? So we have the less than is LT, the less or equals to. Remember the L is less and E is equal. Okay. And then we have the E equal double. So this is normally very confusing, but we use this one in comparison. Like we can say You can compare two items. Let's say you compare one car, which is maybe a Toyota, and then you compare that Toyota to maybe a Honda. Those are items you can compare based on what you're looking for in their comparison. Let's say the number of passengers it carries or the engine size and all that. So that's comparable right there. But you can also say you can compare by negating. So negating means we are basically assigning, but we say not. Don't assign it. So we pay, this one exclamation is a not. It negates the plus sign. So instead of putting 2, we just put 1 here, so we negate it. And that's negating as in, if this is not equals to that, then do that. If this equals to that, then do this. So this is going to be a negation. And then we have the greater than or equals to. And then we have the greater than. Okay? Operator overloading still. Okay? So this again goes into detail on how we actually apply the plus sign. Can be used for like overloading, or as in integers, or as in floats, or also as in strings. So the same concept, just elaborate. I'm trying to elaborate in there. And then here, remember we type something to do with the complex numbers. So we can say, we declare that as a class, and then declare that as a function. We pass in the function parameter. This and that are parameters. Okay, then we come and say, we want to assign the word real, which is a parameter up there, to self.real, and then imaginary to the word self.img. And then we call, remember if this is 5, this is 3, this will be corresponding to that real, 3 will be corresponding to imaginary. And then 5 and 3 here will now be the arguments. Remember the real is a parameter and the imaginary is also a parameter. Down here, the values of those two parameters are going to be the arguments. So 5 is the argument to the parameter real. 3 is the argument to parameter imaginary. So using the complex calculation, we should be able to assign, we call that function imaginary complex, which is, we call the object or the class, here we call it here, and then we do calculation using it. So this is also another way of how we can apply the operator overloading. Okay. Now remember, this will throw an error. Okay, it's not going to work, and that's by design. So the error it's going to throw is going to be this one. So it's unsupported operand because the plus, for the plus sign complex and complex, this is not going to be applicable there. Okay, if we were to run that, you'll be able to see how that does not work. But I'm going to leave it to you. So when I share the notes, you can do it on your own. Okay, so that means we can see that the operator is not supported in a user-defined class. User-defined, remember, there are two types of classes. We have the one which we can say, quote unquote, naturally exists in Python. It comes with Python package, but we can also define our own. But when you define your own, in this case, it's not going to be supported. But we can do the same by overloading the plus operator for our class complex. Okay, let's see how that works. Okay, this again is basically the symbol, the addition, subtraction, and the equivalence. Yeah? The same operator, basically same thing. I try to do this so it hammers, like you really get to understand it the more you get to see it, especially when you're reading. Okay, the same rational operator. Okay, so we did the overloading here of what we basically touched before. So this one works. Now it works because we did the same, the real number and the imaginary number, the I and the R. We did the same thing, but instead of, let me go back. Imaginary and real. Now, instead of just doing that, we make a function, and that function we want to call the add for adding. And then the real and the imaginary, remember we assigned them up there. So we are going to say add the real number to the real number, self to the real, and then add the imaginary number to the imaginary number, and then return what you get. So if we do this, we should be able to come up with the answer, which is going to be this one. But if we don't do that, then we will not be able to come up with an answer. So here we use add and we use string operator overloading, and we are able to come up with the sum of 7 plus 7, which is C1 plus C2, which is, as you can see, are going to be those ones. Okay. So remember this point here. Okay. So we can see that the operator overload operator is not supported in a user-defined class. You can define a class, but it's not going to work. Like we did that. This is user-defined. It did not work. But it can work only if you call this one, which are naturally occurring. They're already bundled in Python. Okay. Okay, that's good for that part. So I'm gonna go ahead and skip quite a few of these because they're basically just hammering the same thing over and over. Okay. That's another example, but this time we're just doing the addition, trying to get to where we wanted to get the radius, and then based on that we set the radius, and then we go ahead and get the radius, and then we do the pi, which is 3.14 or 22/7. We multiply by the radius times, remember, this one is exponential. So we say raised to the power of. So it's going to be r raised to the power of 2. And then we do the addition here. And then we go ahead and see what the result's going to be. So that should be able to, this become possible because we have overloaded the plus operator by adding a method named the add, and then we do that. So we are able to come up with a solution to that. But I want you to remember, if you don't do that, you do your own, the plus sign might not work for you. So the more you work on this, the more it's gonna hit home for you. So again, I repeated the same thing here, and different how they appear, you know, self, other, index, and all that. And then this is sorry. This is a program which is using some of the above mentioned functions to overload the operators. So return, we define basically it's the same thing. Okay. Some examples here which I used. Okay. So that's how the operator overloading works. So before we go to the next section, any question regarding operator overloading? It appears like it's a wide topic, but it's not. It's just a shortcut on how you'll be able to work with operators, how you can overload them, and also to help you understand, let's say one day you encounter something like that kind of, instead of somebody using a plus sign, they're using the underscore, underscore, add, underscore, underscore, open and then close the parentheses. Then you should be able to know, oh, they're using operator overloading. Or they could be using less than, greater than, you know, equal sign and all that.
Hey, George.
Yes, sir.
This is Robert.
Yes.
Quick question.
Mm-hmm.
Some basic question on operator overloading. Which document do you have it on Google Class? The classroom, which document do you have this reference to?
You probably came after we started, but I wanted.
Probably, yeah, I did actually.
Say again?
I came after you guys had started.
Yeah. So I declared, I proclaimed that this is something we have not touched. It was intentional, and I started it so that we can touch it because it's going to be based on what I'll be sending you guys in the Google Notes.
Okay, got it.
Yes, sir.
Thank you.
Mm-hmm. Thank you. So right now you should not be worried. We just want to get it out of the way because it's a short one, but it's basically on what we've done before. It's just much more detailed in this case. Okay. Any other question? Anybody else? Okay. So we are going to go ahead and go back to the objects.
Excuse, I just wanted to ask on something.
Say-
I also came a bit late, but just before you move to the next, I would really want to know about this self that we include within the parameters. Is it a keyword? What exactly does it do? Are we able to use a different word for it so that it is not self?
Yeah, that's a good question. So self is actually like a keyword, but who asked the question? Lucy?
Lucy.
Yeah. Lucy, you can actually use any other word. You can use any other word. Say, for example, you want to declare, but you can use your own name in there. You can put, instead of self, you can put Lucy, but that has to be there.
Okay.
Did that answer you?
Yeah, and I really wanted to know, like, when we include it, okay, it is like we really have to have a parameter self, or maybe if I call it anything, and then it really has to be there.
You can declare a class, and then you instantiate the class using the underscore int underscore, and then you open the bracket, and you have to declare. You can put self, right? The word self.
Yeah.
It's a requirement, but you don't have to use the word self. You can use any other word, but it has to be there.
Okay, I get you now.
You get me, right?
Yes.
Okay. So in my case, I'll probably say we declare we declare class, and then we go ahead and instantiate the class.
Yeah.
Once you instantiate the class, then I would like to use, let's say, the name of my dog. I say Jack. I say Jack, then whatever comes under there within that parentheses will now be followed by parameters. But before you do those parameters, the word self or any other word you like has to be in there. So that when you come and then you'll be specific, Jack dot that, Jack dot this. So those dots will be, for dot is the parameter. Say I say Lucy, and then I say comma, name, for example, name, comma, email. Okay. Remember, I've already instantiated it. So I say now Lucy dot name, Lucy dot email. Just the same way I would do self dot name, self dot email, self dot address. So it has to be, the word has to be there, but it does not have to be self. It can be any other word, but it has to be there. Okay. All right.
Thank you.
You're welcome.
Thank you.
Okay. So now, remember we did the classes. Classes are big time thing we need to always make sure we remember if we can. So there are two common programming paradigms we use in Python. We use the procedural and we use the object-oriented. Now, the procedural programming uses a series of steps to tell computer what to do. Those are very simple. Okay, procedures. Put a procedure there, put a function there, call it. Now, procedural programming extensively uses procedures. We can think of a procedure as a function or a block of code with a particular function specific to it. Okay, such as, let's say, calculate the salary of this guy. So we know in the salary, we have to have the hours worked and we have to have the rate of pay. That could be in itself a procedure for a function. We can also say, I would like to create a program. The program is going to be too big, but I would like to be able to come up with a way whereby I will be calling this function for, let's say, when I need salary, I just call that function. I don't need to declare it again. So it's going to help you avoid repetition and then avoid unnecessary long programming, and also makes your program look easy to read and very professional. Say if you're designing maybe a scientific application where you need a lot of formulas, conversion, you convert from meters to centimeters, from, let's say, miles to kilometers and all that, you probably want to put those in function. Now remember, if you are declaring a function, you don't want to overload one function with several other procedures which are not related. So if it's conversion of kilometers to miles, then just put a function of kilometers to miles. If you need another function for, let's say, miles to kilometers, do another one for mile to kilometers. So one function is always good to have its own unique name and its own function. Function as its own work or use. Okay. So we can think of procedures as functions which perform a specific task, such as calculate the incentive of an employee, save the data to the database, or run backup, and so on. So if you do that, then it's going to modularize your program. Your program will be very, very easy to follow, very professional, and really good. Now, the object-oriented programming is way almost opposite of what procedures are. So this is the other side of the coin. We had the head, and now we are looking at the tail. Now, object-oriented programming revolves around objects. Now we know Python programming by nature is an object-oriented programming language. So we declare almost everything in objects. So instead of procedures, we have them in objects. An object is an entity which contains data as well as procedures that operates on the data. Okay, the data and the procedures inside an object are also known as attributes. Say, if we declare an employee, we say employee name, employee, there's employee rate of pay, works, hours worked, and all those are attributes to that employee. If you say a car, you say the car's name is, let's say, a Ford. The model, the color, is it left-hand drive or right-hand drive? Now those adjectives describing that particular object, which is the car, we call them attributes. Okay. So out of those attributes, you can come up with, let's say, a function. Or in this case, when we are doing object-oriented, now we don't call it functions, we call them methods. But if you are in procedural programming environment, then we'll call them functions. Now, there's no big difference between function and methods. They're more or less the same thing, just depends on the paradigm we are talking in. Now, before we create objects, we first must define a class. A class is simply a template where we define the attributes and the methods. Okay. When we define a class, we essentially create a new data type. It is important to note that class is just a blueprint. If you have, let's say, you have a drawing of a house. It could be 2-bedroom house with a bath, toilet, kitchen. That is a blueprint. Now that blueprint might be for house A, and it can also be for several other houses using the same blueprint. So it doesn't, in itself, it does not do anything. Okay, now the same thing, to use a class, we must create objects that are based upon the class itself. Now an object is known as an instance of a class, or a class instance, or just an instance. Now the process of creating objects from a class is known as instantiating. Now remember when we introduce the objects, we use the underscore, int, underscore. That's the instantiating. That's the way we instantiate an object. So you'll see here shortly. Okay. The syntax of defining a class. So we say the class and the class name. And then in the class, we have the parent class. And then we have the method. The methods could be like several methods. Now for Python programming, in your case, Lucy, before the parent class name, there will be following with a lot of parameters, but we have to declare the word self first before anything else. Okay. Let me see if I can bring this up here real quick. Okay. Oh. All right, so here, the same notes, okay? We have the classes, we have a class is like an object constructor, okay? So we come all the way down there. Okay. So, and I'm assuming probably everybody got a chance to read this. So basically, I'm gonna rush through it. So when we say instantiate, then we call this function instantiation. It basically call and execute the object. Okay. So remember, when we define a class, we have to use the word class and then the class name. Okay. If you don't do, like, this is just a comment. You can just say pass. When we don't do the pass, then we might be able to generate some errors. So we have to be able to do that. Okay. So we can say define a dog, then we call that without passing any parameters. We can just go ahead and say a dog, and then this is just a documentation part of that, describing what the program is going to be doing. And then we do that pass. Okay. So some of the conventions, like Python class names are written in capitalized words. Right there. We call them I would call them a camel case. Okay. For example, a class of a specific breed of a dog, like German Shepherd, would be that one. So we come here, we declare, and then we make sure that we instantiate that class. Okay. So the dog, call it, we declare the dog class, and then we say define. Now remember, define goes for the function, but when we are in object-oriented programming like objects, now we call that a method. So this is an instantiation method. Now for you, this should be able to still work for you if you do that. It does not have to be self, but if you do that over there, it has to be all the way. You can use any word, but it has to be consistent. So yes, it's a keyword. No, it's not a keyword, but it has to be there, and it has to be all the time. Okay. So we go back to our, go back here. Now, once we've seen the syntax on how to declare a class, now we come back to the class definition, which is divided into two parts. There's the header and there's the body. Okay. The class header starts with the class, which is right there, the dog. Okay. The header, that's the dog. And then the class body will now be the attributes. In this case, will be the attributes of what it's going to be doing right down there. Okay. So we follow that by optional parameters. Now the parameter does not have to be in there. Remember, just like in functions, we don't have to have parameters when it's not supposed to be there. But if it's there, it has to be used. So inside the parentheses, we have the parameters. Now the class name and the parent class name can be any valid parameter or identifier. Okay. Now the parent class name, class refers to the class you want to inherit from. So when we declare a class, the class dog here, this class will be the parent class, but we can inherit this class in other programs. When we do the inheriting, then we'll be calling this class as a parent class, and the class which we'll be calling it will be the child class. Okay, so there's parent and child. Okay, so the parent class refers to the class you want to inherit from. So this, right now, what I'm talking about is to prepare you for what we will be covering, known as inheritance. And that will be deep into the object-oriented programming, and you'll see how reusability comes about when it comes to object-oriented programming. Say, for example, you did a program long time ago. You did what you did and you finished it. And then you maybe change companies, or you have another program which you need to do, but you know very well you don't want to do it again. You can just go and inherit some of the components or the functions of the previous class. So when you do that, you're basically inheriting from that parent class and using it in this new child class. Okay, so that's called inheritance. Now, if you don't specify a parent class name while defining a class, it will automatically be set to be an object. Okay, but that will be discussed when we start touching on the inheritance. Okay, so this again is just a class for a circle. We know we want to get the class circle, and then we instantiate. Now remember, this self, it's always good to have self, but you can always have it in your own doing. It could be your own name, it could be the name of your own favorite musician, whoever that could be. So after that, then you go down, you get the area, okay, and then you get parameter. Now just know the area will be the multiplication. And remember, you can always do the overloading here if you want. Okay, and then here you do the perimeter. Of course, the circle itself will be all round. So that's the that's going to be, should I say the area around the circle being the perimeter? Maybe, maybe not. Okay, so, but you know what I mean though. Okay, and then you go to the next one. Now remember, in line 1, we import the math. So Python has libraries which have already been done for you, and that's why it's so easy to program in this language. You just call. So the math will be for, in this case, it will be having stuff like the Py. It will be having libraries which can readily be used. Okay, so we are importing the math module because we will be using the Py constant 3.14. Now in number 3, line number 3 here, we declare the class. We have a class header, which is the class name, okay, the circle. And then with the class keyword followed by class name, which in this case will be circle, followed by a column. We have to follow that by a column, okay. Now in the next line, we have class body. Now the class body will be the instantiation, and then we get the area, then we get the parameter. Now these 3 will be the methods. If we were in procedural programming, we will call them functions. It's interchangeable. Sometimes I even make mistake. I call them function when I'm supposed to call them methods, but it doesn't matter so long as you understand and you're on the same page. Now the syntax of defining methods is exactly the same as that of functions. If you can remember functions, notice that each method has first parameter named self. So we can call that self Lucy in Python. The self or the Lucy parameter is required for every method. The Lucy parameter refers to the object that invokes that method. Now Python uses that self or Lucy parameter to know which object to operate on inside the class. While calling the method, you don't need to pass any value to self parameter. You don't have to. Okay. Python interpreter automatically binds the parameter to the object when a method is called. Okay. Are we together?
Yes,
All right.
we are.
Okay. I know this is technical, but
Yeah.
just bear with me. If you did not read the classes and the objects, this will probably be also a good time to just listen in. When you go read, you probably get the hang of it. If you have questions, please feel free to ask. Now the syntax of defining methods is exactly the same as that of functions. We just talked about that. So when you go back here, see the way we do with the class, the same way we do the function. So we define a class and then immediately we call, this is a class. The same way we do the function. So remember, this is a function, it's also a method. Okay. The reason why we're doing functions and methods, because sometimes we don't want to repeat the same argument over and over. We just want to call it. If it's already been done, we don't want to reinvent the wheel, we just call it. Some of the functions might not be yours, or the methods might not be yours, but you might be borrowing from other people. In this case, the word math there is actually a method. Now we will call it a library. Somebody did that, now we're calling it. If you call that, we just import it. Okay? And you'll see a lot of this happening. We will, at one time, we will also do our own library, and then we call it. We can do our own library based on something specific, which might not be existing already, but we know it's very important to have. For example, we might just need to be able to convert. Let's say we want to convert the currency of Kenya, Uganda, and Tanzania, but we know there's no function doing that. We can actually do that on our own, and then we call it. So when you call it, it will be part of the program. So we call it by importing it. So when we call it by importing, we can also actually, if it's like in the same program, we can just go ahead and inherit the class, if it's a class. When we inherit that class, the class we inherit is going to be the parent class. But the inheriting class, the one we're going to come up with, is going to be the child class. Okay. So that's explained right there. This is basically explaining what we did in the perimeters and the area of that circle. So I will not go into detail, but when we share the notes, you'll get this. Some of these notes are more detailed compared to what I provided before. So this will be beneficial. Okay. So remember, defining constructor method, this one, is not a requirement. It's not. If you don't define, then Python will automatically supply an empty init. I call it init, short for initialization, method which does nothing. Okay. Now, if you go to line 6, right there, okay, self.radius equals to radius. The instance variable self-radius is initialized to the value of radius itself. So we actually take the value of radius. If we had that as a parameter, now here it will be a value inside it. It's a memory we assign to the word radius. In other words, the above line of code creates an attribute. Attribute is the behavior, so to speak. How do we describe it? Okay, attribute named radius within an initial value for the object that was just created. Okay. This, again, detailed explanation. Okay, so I'll go ahead and skip that. Okay. Now, creating the object. We can create objects from a class by calling class name as if it was a function. This one, like a function or a method. However, if you have defined that init method, then you need to call class name with arguments as follows. Okay. Remember the arguments. One of them will have to be the word self. If you declare without the word self, then you stand a chance of it not running. The argument must match the parameters. If there are 3 arguments, you have to have 3 parameters. Okay. If, let me bring that here. 1, okay, we have name, breed, color, and age. Those are parameters. Now, when you come here, you use the same parameters, but now you assign values. In this case, you assign name to name, but you use the word self here. So the number of parameters they have to match the number of arguments. Otherwise, you get an error. So 1, 2, 3, 4. 1, 2, 3, 4. Remember, we did not count the self or the Lucy here. Okay.
Question.
Is that good?
Yeah, I have a question. Can you hear me?
I can hear you.
Yeah. So if you go back to the notes, and I think it's, yeah, the Word document,
The notes here?
right. So if you scroll down, I think it's page 14 also, it says in my notes.
Okay.
So you said about if you pass 5 parameters, you also have to give 5 arguments, right? Or I'm not paraphrasing you correctly, but the number of parameters have to equal the number of arguments, right?
Yeah, they have to match, yes.
So I got confused in this one here, and I know there is some notes that you said first save it somewhere, I think, so you can delete the previous parameters. But in this example, we are only passing the name and the age for, I guess, the dog Jack. But then our code down there,
Okay,
I
here we
think
pass
it's in
the age and the name, right?
right. But I think up a little, there is more to the class than just that. We still have the color, the breed, and all that.
Yeah.
Because when I tried to run that, it was telling me I'm passing more parameters and giving less, some kind of error.
Okay. Do you have do you have it like somewhere you can share screen?
I hope I still have it. Yes.
Okay. You wanna share? Let me see if I can make
Yeah. Maybe I did it wrong, but okay. It's the learning time, right?
Okay, go ahead and share.
Um, wait a second. Tell me, am I sharing Anaconda? I think, right?
Yeah, I see it. Can you scroll
Okay.
up?
So how do I get this number?
Can you scroll up a little bit?
Yes.
Okay.
So we only have the name and the age, but then in ourselves, we are declaring 4 parameters, right? I mean, 4 attributes. I have to get this straight, but yeah, you get what
Okay.
I'm trying to say.
Yeah.
So when I try to run this, yeah, takes 3 positional, the color, I mean, the breed, and then of course the species. So where are we going wrong?
So you done?
Yes, yeah.
Do you want me to jump in?
Sure, go ahead. Yeah.
So, okay, right here, we have the species, right? And then we are going to go ahead and declare just the name and age.
Mhm.
And then the name, we assign the name. Of course, we use the self.name. And then you see the age. Now I added the breed and the color.
Right.
And then you say, now we call this self, but we say we want just the name and the age.
Mhm.
And then the sound, did you copy this from the same?
Yeah. Yes, I think I did. Yeah.
Okay. You didn't mix them up?
I hope not. But if I did mix them up, just point me in the right direction, and I'll do
Okay.
it again, so we don't take
Uh,
everybody's time.
Okay, no problem. Let me see here.
Yeah, because
So,
I'm looking at page 12 in the notes,
yeah,
and you're kind of getting an output. I'm not.
page 12, right?
Yeah. Oh, never mind. Sorry, that's a different one.
Because I think you mixed them some.
I may have.
It's,
And
everything, you see, like my screenshots, those are the examples I get when I run them.
okay, I'll try again then. I was just trying to
Yeah,
go
like
by that hand.
like you see, just underneath that long program, there should be Jack the dog and then Jack dog brown 4. That result came from running the top one, right?
Yes, the top one is correct, the one that had all the parameters and everything. But then when it
Mhm.
came to now the other methods, the descriptions and the speak, then that threw me off.
Okay, which one? Because I don't see the one you're talking about. The one below?
So my confusion came in from number 11, I mean page 11, where it says this dog class has 2 instance methods, description and speak. Then it says to save the modified dog class and press F5,
Mhm.
then run it. So when I tried to run the other one, then I got all confused.
Okay. So do you mind, Monica, if maybe we'll take this offline with you, and then I'll walk you
Sure,
through.
let's do that. Yeah, so we
Is
don't
that
waste
okay?
everybody's time.
I
Yeah.
think I can help a little bit. Why
Okay.
it says define init self name age. She should add the breed and the color to there. Because that's what it's missing.
Mhm.
Why you said define init
Uh-huh.
self name age. Add
Right, so it can be like the original one. Okay, I'll fix that then.
yeah.
All right, thank you.
So
So I'll
is
stop
that
sharing
clear?
and then we can go
Is
on.
that clear for you?
Yeah, it does.
Okay. So what do you think happened? You mixed them up or you missed something?
I may have mixed them up
I
from,
think she
I don't,
missed something.
yeah.
No problem.
All right, thank you though.
Oh, thank you. Okay, that's the program right there, the one you're looking at. But remember, if you still have any questions, feel free, please,
Sure.
to get hold of me so we can work it out for you. Okay, so I say it's very important when you declare the variable, if you know you're going to use the parameters, if you know you're going to use them, they have to be lining up with the arguments and the parameters. They must match in the init method without self. So don't worry about the self, the Lucy one, right? Lucy has to be there, but the parameters, they have to match with the arguments you're going to use. Otherwise, you get an error. Okay. Okay, so here's an example. So we say this circle 5, the above state does not follow the string. So we create an object, invoke that method, passes this newly created object self, and then go ahead and do what we need to do. Then we come up with that. So this is just an example. So this will also I'll share so you can have a look at that. Okay. All right, so accessing attributes in a method. Once we have an object of a class, we can use it to access object attributes. Okay, or instance variables and methods using the following syntax. Remember that syntax to access attribute. So if we had the word object or Lucy here or self here, then it's going to be self.attribute, self.method, argument. Now here is how we can access attribute and methods of a circle. Come here now, we go ahead and say, now print that circle after we import, okay? Do that, then we go ahead and say, whatever we do in my circle has to be dot radius, or my circle to get the area. And of course, if this is throwing you off, this is just for 2 decimal places in a float. That's the way we use formatting in printing statement. Okay? So I have a program of this nature I'll also share so that you can have a look at it. Now notice that while calling instant methods, we are not passing any value to the self parameter because Python automatically passes reference to that or to the object that was used to call the method, the self parameter. So in this case, the object referenced by the my circle is passed to the self parameter. So like I said before, those attributes, you have to follow them with the word, like if it's self or it's Lucy or the word you chose, it has to be dot, that, dot, that. Okay. So let me see if I can give you that here. Name and age. Remember, self is still here. So when we want to use that, this is a parameter. Now we want to pass the attribute. This is an attribute. This one, that one, that one. We want to pass them into the parameters. So we have to use the self dot color, self dot age, and then we bring them in. So if we do that, then let me see if I can run that for you. Might not have any printout yet, but that's already a past thing. So if you print, if you go in, you assign them, then you'll be able to come up with, in the memory, you'll be able to come up with those assigned so that when you're ready to print them out, they'll be coming out the way you want. Okay. Okay. So go back here. Sorry. So we have some more reading there, and then pretty much that's it for objects. But I know objects is very critical and very crucial for this, for anything you do in Python. I'll hammer more in the notes, I'll share, and then we take it from there. Okay. Our next one will be functions. This will just be a second nature now. Now that we've talked of objects, I touched on functions in the lesson plan before I introduced objects because I knew you cannot talk about objects without referring to functions. But here I put them the other way around for understanding. So we have 2 types of functions. We either have a built-in like L, EN, or print, or input, or string or float or integer. Those are inbuilt. If you don't have a function built in and you want to use the function, you need to come up with your own function. When you come up with your own function, the function you come up with is going to be known as user-defined function. Now, the name of that function has to be descriptive. It's not a must, but it's a good thing to do. So function is named group of Python statements which perform specific tasks. The syntax of defining a function is as follows. So this is just an example, but this is the way we define the function. So use the word diff for defining function name, and then you pass the parameters. Remember here you don't use the self, don't mix it. Once you use the parameters here, now you go to the body function. And the body function will be your statements, the way you would like them to appear. And then you don't have to, but you can use the return statement, but you don't have to use the return statement. There's some situations where you really don't need to, because return is supposed to return a value or return something back to you, but not all functions return anything. You can also declare a function which might not have any parameters in there. It could just be blank. Okay. And remember, we talked about functions. If you read it, we spoke of lambda functions in our previous in the Google Notes. So lambda functions are also another type of functions, which we call them anonymous functions. So when we declare lambda functions, let me go back here, see if I can get it back here for you. Okay. So we have built-in functions, we have user-defined functions, and then we have lambda functions. Now, what do we mean by lambda functions? So, now, lambda functions are anonymous functions, which are also popularly known as lambda, and are custom made without any name identifier. Lambda functions can take any number of arguments, but can only have one expression. Okay. If you read this, you probably got some of the examples I used. Okay. So this is how you declare the lambda. You have to use the word lambda, and then the argument, then the expression. So you come here, you say double. Double could be equivalent of a float. And then we declare that with a variable, and then we have to follow it with a column, and then what it's supposed to be doing. So this program shows the use of a lambda function. And then we print out, remember, that 5 will actually be this one. So this will be the argument, and that's the parameter. If we take that 5, we put it here, we multiply, we have to get 10. Let me see if I can run it so you see. Sorry, this class today is a little longer. I hope it's okay with everybody. whatever we get from here will help us a long way. So we come here, we can say the lambda function, we run that, gives us 10. So lambda is something you can use not very commonly, but there's some very specific ways you can be able to use that. Okay. And I think I use an example of a map and a filter, how you can use those. And I probably don't go into that for now. So I'll share those with the notes. I think I also did before, like the filter here and also the map. So in Python, we generally use lambda as an argument to a higher order function. Now, a function that takes in other functions as arguments. So we can use lambda in other functions, in this case, filter and map. So lambda is used along with those ones to maybe filter out, say, for example, one thing which we want to isolate. Okay. Let me run this one so you see. All right, so we say program to filter out only the even numbers. Okay, we're using lambda function with a filter function to filter out. So we go ahead and say 1, 5, 4, 6, 8, 11, 13, 12. We only want to be able to say, remember this is a modular or modular division. When you divide by 2 and you get a 0, that number has to be, the number x has to be an even number. So if that's the number, then we go ahead and print it. Okay. We assign it to new list and then we print it out here. So let's go ahead and try that. So here we only get the numbers which are divisible by 2 and we get 0 as a result. So if we add 13, then we put 14, maybe we put 18, then we try again. So whenever the number is divisible by 2, we'll be able to get 0. Let's try that. Now each time you try, you add even numbers, the list go higher and higher. Okay. All right, so we come back here. So that's a good distinction. Remember, you don't have to have the return statement in a function if it's not returning anything. So a function consists of 2 parts. Also, just like the classes, it has to have the header and the body. The function header starts with the define or def keyword, followed by the name of the function, and then followed by the argument, and then ends, it has to end with a colon. Okay, like that. Now remember the parameters here, or the arguments here, don't have to be there. It could be like a function without those parameters. But remember, it has to have the definition or the file, def, and then the name of the function. Okay. So def is a reserved word, so you should use it as a variable or function name in your programs. So if you do that, might just be a little bit of conflict there. So function name can be any valid identifier. Could be your name, the name of your pet, maybe your favorite movie, whichever. Depending, it has to be very specific to describe what you're trying to achieve. After the function name, we have a list of arguments inside parentheses, separated by commas. We use these arguments to pass necessary data to the function. The function can take any number of arguments or none at all. If function doesn't accept any argument, then the parenthesis is empty. So that means it returns 0. Now, nothing. In the next line, we have a block of statements or function body, okay, which contains some statements. So let's look at that. Okay, let's go back here. Of course, you remember the indentation. It's very important in Python, and it has been blocks. Okay, all the statements in the body function must be equally indented. So if you want to use one space, then it has to be consistent. If you use 4 spaces, make it uniform across the board. So make sure you pay special attention to the last statement in the function body, the return. Return statement you use to return a value from the function. Say you pass 2 parameters, which is rate of pay and hours worked.
Did we lose Mega?
Yeah.
Can you guys hear him?
No, we can't hear him. No.
You can't hear me? Can you hear me? Can you hear me now? Okay. Can you guys hear now?
Migot, we lost you for approximately 2 minutes or 3. You're on mute. You're on mute, Migot.
So can you hear me now?
Now we can. Thanks.
I think I had a disconnect on my internet for some reason, just for a few minutes. Now, sorry about that. So let me go back to maybe where I thought we. Now, in the next, like, just remember we have a block of statements or function body. Okay, the body contains statements which define what the function has to do. Now, the indentation is very special. We have to make sure those work, and it has to be consistent. If it's 1 space, it has to be 1 space across the board. Or if it's 2 or 4 spaces, those indents, they have to be there. Python relies on those. Okay. Now, pay special attention to the last statement in the function, return statement. The return statement is used to return a value from the function. The return statement is not a mandatory requirement. So some functions don't need it. Depends on what you're working on. But some others do need it. If you have, let's say,
I can't see your notes. Can you maybe broadcast them on the screen?
You can't see?
No. I don't know if it's just me, but let me see.
Can you see now?
There you go. Yes.
I'm sorry.
That's
Today
all
is
right.
a different day for us. Huh? So return statement, it can be there, but it's not mandatory. When it's there, it has to be useful. Like, remember the program where we had rate of pay and hours worked. Rate of pay and hours worked, we put those in a parameter, and then we get the values in. The values will be the arguments. In the return statement, we can actually open and close the parentheses, but inside there, we can do a calculation. So if we say 5 times 3, it's gonna be, if the rate was 5 and the hours worked was 3, then here will be almost equivalent. It has to be corresponding, and then we can easily return that as a result or as a return statement, and then we print it on the screen. Now, if a function does not have a return statement in the body, then a result word none is returned automatically. None is actually an object of a built-in type, none type. Okay. So we have this one right here. Sorry. Let's see here. This is just, we import the date and time, and then we define the greet function. And then we print the word in Swahili, habari zenu, and then we say today, and then we call this import dot date time now. Like right now, it's going to give us the time and date as of right now. Now the greet function does not accept any arguments in this one. That's why parenthesis is left blank. The function body contains two print statements. The habari zenu and the today is. These two statements will be executed when we call the greet. Okay. So let me see if I can do that for you. This import. Say great. All right, let me share this on the screen so you see it. So we import, once we do the importation, right, at this time it's still not knowing what we're trying to do, right? So remember, this one, if you're following, then we'll tell you invalid syntax error. There's something we forgot. What did we forget there?
Column.
That's correct. That's a colon. So when you do the colon, or you do without the colon, then you're going to be having a problem there. So we say now print. So can we call, run it again, still get that. Then we say now, based on that, we can go ahead and do another run. And then we say today. And then we come back here and then we say, remember when we call that, we call the date and time. That date and time is the same one, we have to bring it here. And then same thing, date and time, and then now. Now is a function for like right now. Now, if we do this, we run it. We have the print statement, but it's not printing. Why? Any ideas?
There's a colon where there is after is, right?
This one?
No, today is.
This one?
Yeah.
That's actually, it's in within the quotation, so it does not really matter.
Okay.
But remember, when you declare a function, you have to call the function for you to be able to get a result of what that function is doing, right? So we have to call it. So let's try that, see what it does. Still not doing it. Why?
Actually, I think you have to indent.
That's right, the indentation. So when you do the indentation now, you should be able to get some results. So sometimes you'll be scratching your head like, why is this program not running? You know, what's going on? Because it did not indent. But sometimes it does not even tell you. See, it doesn't tell us. So we don't know what's going on. So it's always good to indent. You see, the color coding, most of the IDEs will give you the color coding. If it's the same group, print will be in there, but this one will have to be indented for us to get it. Okay. So we come up with that. Now remember, we call the greet function does not return a value, but we declared it without those values. But when we call it, it basically uses whatever we give it to return as the result we're looking for. Okay. Now the function call, we have to call the function. You can design and do beautiful stuff, but if you don't call that function, it will not do anything. So the function definition does nothing by itself. To use a function, we must call it. The syntax of calling a function is as follows. So if we have this as a function name, we do the arguments or the parameters. And then if the function does not accept any parameter, then you just use it, do it blank. And then if you do it blank like that, that means we are calling it. Okay. So the following code is also the same one we just did. Now we did that, call it, we saw how it works. It's good, but if the function call must appear after the function, that means if this comes before if this greet comes before the word greet, then we might get an error. It's going to be name error. So it has to come after in the sequence. It has to be after the name, the function, the name function greet. Okay. Okay, the function call is called a program control with jumps. So anytime we call that, it jumps back and forth, could be depending on where the function is at. You could be having just one file full of functions. And then that's the file we import. And then anytime you import, you want to be very specific where you want it to jump to so that it can grab what you want it to go get from there. So after executing the body of the function, the program control jumps back to part of the program which called the function and resumes. It resumes the execution from that point. That means right now we are here. We execute from the top, go to the next line, third line, fourth line, and then we call this one. This one will basically call the whole of that, and then executes it, and then prints it here. And then the execution will return to the next line. If we had anything down there, then it will continue to the next line and go in that sequence. So that's what it actually meant here by after executing the body of the function, the program control jumps back to part of the function which called the function and resumes execution from that point on. Okay, this is again the same thing. So we do that, greet, hello, we go back, print it, and then once it's printed, then it goes to the next one. So we say, let me go ahead and print that real quick. And after. Okay. So here we are, before and after. Print that. It does print Habari, print today, date, and then print that, and then return. You see, we call it here. We did that execution, and then return, and then continue to the next one, which is the after. Okay. That's good. Okay. I hope this is clearing some of the confusion you might have had on the program with the functions. Okay. So this explains what we just talked about. So you don't need that, okay? Line by line. And this is just a diagram of how that works. We call it from here, and then once we execute it, then we proceed to the next line. Same thing. Okay. Function call, same thing now. But this time around, it is not unusual for programs to have hundreds and hundreds and even thousands of functions. In Python, it's a common convention definer function called main, which gets called when the program starts. Now, if you touch any other language like Java or C or C++, we talk about the main program, but in this case, it's going to be different because this one you use it as a user defined. Now, the main function here then goes on to call other functions as needed. So the main will get called when the program starts. And then somewhere in the memory, it will keep it, but each time you call that function, it will automatically execute it. Now the following program demonstrates how the program control works with the main. Okay, so we do that, call Habari, then here, I'm gonna have to type this out so we see what it does. Maybe not, maybe I'll put this in the notes so you guys can try it on your own, just for time's sake. So it comes here, prints, then when we call this, instead of doing the, remember doing the main, the greet here, we define another function. And then that other function is actually calling the first function and then keeping it. So when we call the main function will go ahead and execute the first function. And that's, it helps in terms of when you have like several hundreds of lines of codes in functions. And that's where we go back here, say, it is not unusual for programs to have hundreds, even thousands of functions. It is a common convention definer function called main. So main is going to be for you the mother of other functions, which you use for calling other functions. So each time you don't have to remember other functions, but you just call main to execute other functions for you. So that's what this is about here, okay? So this exactly explains the line numbers and exactly what I just said. Now the main does not accept any arguments and has 3 statements inside the body. So here you see it does not accept any arguments, but it has 3 statements. Now here we say we print main, function called, greet Jonathan. Okay, that's the name. So remember this name is gonna be with that name variable. So print Habari Jonathan, today is, and then it's gonna print there. It's gonna print the today's date and time. And then you print the day, function finished. So when you call this, it's gonna take care of that. So I would, for the sake of clarity, I would say the main function is the mother of other functions here. Okay, you can use it to call other children functions. Okay. Okay. That's the same thing, main. Okay. Now this is something which we probably did not touch, but it's very important. Any function we were working on was like a local variable function. So we have 2 types. We call them scopes. How far can you go in the program for a function not to be able to work? Some of them, they can only belong to a certain block of code. If you go beyond that block of code, that function might not be called because it's not going to exist in that new code, in that new block of code. So local variables, we also have global variables. Now the variable scope or the scope of a variable refers to the part of the program where it can be accessed. The variable we create inside a function are called local. Okay, like this one here. These are local. When we declare function here, these are local. These are local to this. These are local to this. These are local to that. There are cases whereby it cannot be like that. We'll see shortly. So the variable we created inside a function are local, or local variables can only be accessed inside the body of a function in which it is defined. In other words, the scope of a local variable starts from the point they are defined and continues on until the end of the function. Now, local variables are subject to garbage collection. That means after their time is out, they get rid of that. The system, the interpreter, the Python interpreter gets rid of it using what we call garbage collection as soon as the function is ended. As a result, trying to access a local variable outside its scope will result in an error, okay? So on the other side of the coin, should be coin, not coin, we have global variables. Now, the global variable are variables that are defined outside of any function, okay? I shared, I think 2 days ago or a day ago, an example of how you can declare like variables on top of a function. When you do that, you're basically using global declaration of that variable. Now, the scope of a global variable starts from the point they are defined and it continues until the program ends. That means you can call them anywhere in that program. They're globally available. But local variables are only available locally. So that means if you go back here, if you say input statement in here, it will only be input statement until this function is done. You cannot use it after this function. It's only local to this function. But if you declare it up before the function, let's say between line 1 and 3, you declare a variable up there, it's going to be a global variable. And that global variable will exist so long as you want, so long as the program is running. Okay. So, examples here. We say global variable equals to 200. And then we say define a function, and then we call a local variable, we call it 100. So local variable is a local variable and is only available inside here. Print function. So we can print the local variable equals local variable, accessing a global variable inside a function. You can go ahead and actually access that variable up there, the global variable down here, and you'll still be able to access it. So if you were to print this one, it's going to print the word, the number 200. And then when you call this function, that's the name of the function, it will be printing the global, which is an outside variable, and then prints also an error, which is going to be a local variable because it's not available. Okay, so I'll share this one so you can run it on your own. That way you see how it works. Okay, that explains what this basically explains what I just talked about previous slide. Same arguments, how we pass them. Okay, argument and parameters. Okay, that's self-explanatory there. So I'll share the notes. Passing arguments. Remember, this is num. This is a parameter. People will always confuse parameter and arguments. So sometimes don't worry about it too much. But just one thing to know is that when you declare it in here, it's a variable. I mean, it's a parameter. So those are parameters for that function. Add 100. When it's assigned here, it's now going to be an argument. Num plus 100 is argument. So when the function add is called with an argument, the value of the argument is assigned to the variable num. And the print statement prints the value of the num after adding 100 to it. So that's also pretty much explains it. Same thing again. We have to call that function. If you declare the following program, demonstrate how to call a function. You can do all this, but if you don't call it, you can't get it back. So x is 100. Remember this x, that one. Okay. All right. That's just for the functions. Okay. Any question on that? This is too long. We have one more section, that's it. And this is a very short one. I hope everybody can hear me, right?
Mhm.
Okay.
Yeah.
So in Python, I remember I shared some notes on file. We call it file processing. And this is like, we've been talking, but what if we talk and then we don't save any work? We basically lose it. The only way we can save work is probably to print the same work in a file or save it in a file. We can do that in several other ways. One of the ways we do it in programming in Python is what we're going to cover here. Now in Python, file handling consists of 3 steps. We open the file, we process the file by performing read or write operation, and then we close it. So we open it. We open it for either reading or writing. When you're done, it has to be closed. Those 3 operations. So what if you don't open it? If you don't open it, then you cannot read it. So it has to be open. Or if you don't open it, you cannot write to it. If you open, you read it, or you open, you write to it, then you have to close it. If you don't close it, Python will be able to close it for you. But it's always a good practice to close it. That way you save unused resources like memory. Leaving a file open might take a lot of information, like in terms of resources from the system. So we always want to do the closing. Okay. Okay. There are 2 types of files. We have the text file and we have the binary files. What are text files and what are binary files? Okay. A file whose contents can be viewed using a text editor is called a text file. A text file is simply a sequence of ASCII or Unicode characters. Python programs, HTML source code, like your notepad, let's say whatever you type in there you save, those are examples of text files. On the other side, binary file stores the data in the same way as stored in the memory. For example, an MP file, an image file, a video file, Word document, those are some of the examples of binary files. You cannot read a binary file using a text editor. It has to be a special way of reading it, okay? Now, before you can perform an operation on a file, you must open the file. Python provides a function called fopen for opening a file. Its syntax is the file object, and then we use the assignment statement, and then we use the word open, and then the file name, and then the mode. Now the mode here, in just a few minutes, seconds, wherever, you'll be able to see what that means. Now the file name is the name or the path where the file is located. The mode is a string which specifies the type of operation we want to perform on the file. It could be a read, could be a write, could be append, could be delete. Okay, now the following table lists some of the differences we have in the modes available. Okay, we have the R for read, open the file for reading, if the file already exists. We have the W, open the file for writing. In this mode, if the file specified does not exist, it will be created. If the file exists, then its data is destroyed. Okay, so you gotta be very careful here. We cannot write to an existing file unless we are appending to it. That means we at the back, at the bottom. So open the file in append mode. If the file doesn't exist, this mode will create the file. If the file already exists, then it will append a new data to the end of the file rather than destroying it. Okay. Say, for example, you're given a piece of work to do. They say we would like you to create a log file. The log file, we want you to capture the time, everything the system does. When somebody logs in, when somebody tries to log in, they cannot log in. We want you to log every activity, including the read and write of the hard drive, including everything, including their name, their username, their email address, their login ID, and everything. That will be stored in a log file. The log file will be something which we can read to or write from, and we can read from or write to. Now, in a case whereby, say, for example, we want to do auditing, let's say in security, we will always go for the log file. That's what we'll be looking for. And most cases, that's what actually contains the information. For example, if a system crash or there's some breach, the log file is what we'll be looking for. Most of the places, that's what they'll be looking for. A good program should always have a log file. The log file logs all the events happening in that file. The way you do that, you have to read and you have to be able to write to the file. So when you create a program, your declaration, first of all, will have to be file object, and then you want to open that file for whatever mode, in this case for writing. And then when it's written, you have to close it. When you want to read it, you open it again for reading. When you're done in the program, you have to put close to close and reserve those other resources which might be used. Okay. So we can also specify the type of file to binary. Okay. We want to work with in a mode string by appending T for text file and B for binary files. But since text mode is default, most of the files are default text mode, so we don't have to. But it will be always a good thing to put it in there. As much as it's a default, we don't want to assume. So since text mode is default mode, it is generally omitted while opening files in text mode. In my case, I'll include it. So on success, open returns a file object which is associated with the file name specified while calling it. Okay, so here we can say we want to open a file known as employees text file for reading. It's a text file for reading, same as below. We can do either this mode or we just do for reading. So this mode is say read that text file or just read the file. Both either or should be able to work for you. The below example is file object. We open the class, will be name of people in that class, email address, phone numbers, and everything we need. So we can open it for write mode, W for write, or we can do open the arbitrary file in write mode. This is gonna be the B, the binary, okay? Right, so we can do the same, open the binary file for appending. A for appending, B for binary file. So if this file is already existing, we want to access it, we can only access it if we use this mode. A for appending and B for binary, and then we can add additional items into the file. Once we are done work with the file, or we want to open the file in some other mode, we should close the file first using the close statement or method object, this one.
George, quick question.
Yes, sir.
So in the line you have at the top of the presentation, file object equal to open teams A being odd, can you have it as BA?
That would be something you want to try, but I would say the sequence probably matters because we want to do the append to the binary file. But I've never tried the other way around. But I would probably, if you get time, you want to try different and then see what it does for you.
Okay, thanks. I was just curious.
Yeah. Okay. But that's a good question. I'll also try that other mode. Okay. Maybe it might work, maybe not. Who knows? Okay. So that's part of what we have for the files. It wasn't really that long. Remember, I also talked about pickling. In the notes, pickling will help us for those people who will be going to the advanced part of this class, where we can actually take a file like the files here, and then we basically use a pickling or the pickle library to preserve that file for later retrieval. In data science, they do a lot of that. It's almost the same process of file handling we just touched on. So if you read it, or you have not read, if you read the notes, then it's going to make a lot of sense. But if you're going to read it, now you'll be more conversant with it. Okay. So that brings us to the end of what we wanted to talk about today. And I'm gonna open the floor for questions, please. I know it took us long, but it's good that we finished it. Any questions? Any comments? Any problem with your notes? Any problem with the homework? Anything?
We wanted to say thank you.
Thank you, thank you. Thank you guys for that long presentation, and thank you for the patience, and also thank you for hanging in there in the class. I know it's difficult with your daily routines, but nevertheless, you're still in there, which is a good thing.
Thank you so much, Migot, for all the efforts and all the time you take, just not in this class, but outside. I don't take it for granted, so really appreciate it.
Thank you, Lois.
You're welcome.
Any other person, any question, any comment? How do you guys find it how do you find the assessments compared to the notes? Are they tallying, or is there any deviation? Is there anything you can do different?
For me, I think following your emails has really helped a lot, as opposed to going to the classroom, because in the classroom they appear to be mixed up.
Mm-hmm.
So I think we discussed it last week. So following your emails is much better. So I'm studying as they come. So that helps a lot.
Thank you.
You're
I
welcome.
hope that helps a lot, because I kind of like figured out it takes a lot of use to when it comes to Google Classroom. We post it, sometimes could be disappearing in thin air, but it's actually there.
Yeah.
So when we post it, that way it helps. And I remember Saitoti Wainaina, he brought that up. And then thanks to Robert Maraga for any assistance you provide, man. Thank you.
I'm the noise maker.
Yes, sir. Any other question?
Yeah, I have a question, George.
Please.
There's some sample code which runs on yours but doesn't run on mine for some reason.
Say one more time.
You have some sample code on your documentation you shared on your screen a little while ago, and it works on yours from what you demoed, but on mine, when I run it, it's not working. That's a Lambda.
Can you share the screen?
Sure, I can do that.
Let me go ahead and stop sharing. Okay, share.
Let's see. Can you see my screen?
Yeah.
Okay. So this is the Lambda function that you presented about filter.
Yes.
I copied and pasted from your documentation, tried to run it, and it's ending with some list object is not callable. Not sure what I'm missing.
List object.
Yeah.
In my list.
Sorry?
Just looking, should we be calling my list and now the new list? Because the new list kind of has, it's kind of marked.
George, it's on page 15 of your functions and methods document.
Yeah.
I saw you run it and it worked fine. So.
Yeah. So that list object is not callable. Are you able to do this? Are you doing this in okay, you're using this in notebook, right?
JupyterLab.
JupyterLab, right? Copy the same and then access it on see if you can paste it in your Colab.
In Colab, let's see. I've not used Colab so much, but let's try that.
Just open Colab. Yeah, that's it. Just single L. Single L. That's it. It's console.
Console.
File, new, file, new. Paste.
Okay.
Right.
Yep.
I'm gonna have to run the same on my Jupyter.
Yep, if you can try that.
Yeah, I don't know why that is the case though. Yeah.
So how did you get to Colab again? I wanna try
it's
using
Colab single L. I'll show you here.
On the
right there. You see on the screen, colab.research.google.com.
Sometimes when you guys send me programs, I use Colab and then I basically can share with you. I think I've done that with Monica, done that with Luis too. Yeah. So when you receive it, just click on the link, takes you to Colab, and then you can see how I ran it.
Yeah, so I guess then it must be a Jupyter issue then, right?
It could be Jupyter. Oh, that's really weird. Is it JupyterLab or just Jupyter?
JupyterLab.
Okay, let me see if I can bring it up here. It's weird.
Yeah, I can try. Let me try Jupyter itself and see. Sorry.
And I did it on Jupyter Lab and it works for me.
Works for you?
Yeah.
Okay. Then no idea why it's.
I don't know what could be the issue on your end. Look at
Let
this.
me try a new notebook. Oh yeah, then it must be something missing.
Your memory is clogged, maybe something like that.
Yeah. Okay. Got it.
That's good. It resolved.
Yep. Thank you.
Thank you.
Yeah.
Any other question? Let me see if there's anything in the chat. That's okay. Okay.
Thank you, Megat, for your time and this one.
Oh, thank you,
For
Monica.
doing this for us.
You guys are welcome. We hope this will be able to bear lots of good fruits out there. After this class advanced, then you're good to go. You can challenge anything. Yeah. Just make sure you master the functions and the objects. Those are the main things. Not that the rest are not, but most of the programs will be in functions. See a lot of people do a lot of objects. Now you should be able, at this time with all this, should be able to look at a program and you understand how the logic they apply. What do they mean by this? What do they mean by that? It's going to be a good thing. Hey, Jackie, you have any word to put? Probably Jackie's gone, right?
Most likely.
Mute. She's on mute.
Yeah.
Hey.
Hey, Jackie.
Oh, just wanted to say thank you. Thank you for today's class. Thank you for everything. And then the team here, it's just amazing to see the ones who are ahead in class, you know, and have caught up, and then also the ones who just are sitting in and catching up and listening. That also goes a long way. So if people are feeling a little bit like they can't keep up, I can't say how important it is to just at least even come for these classes, and then also just not giving up. And it's so nice to see the people in here who are caught up, and it's great energy. So Megat, I just wanted to say thank you.
Thank you guys. Thank you, Jackie. You've been very helpful. You helped
Yeah,
me.
George, we're going to get you some fish.
Yes, sir. Okay, any other question? I know you guys are busy, but if you don't have any other question, then we'll go ahead and close this session. I'll share the notes and I will also put the video out there for everybody. Thank you.
Thank you so much, Megat.
Thank you.
Thank you.
Bye-bye.
Bye. Take care, everybody. Have a good week ahead.
Sure, you too.
Bye.
Bye.